Lesson 87, more on systems of equations. So in Lesson 87A, we're talking about just a little bit more information on systems of equations. And basically all this is saying is that, oh, hey, by the way, sometimes you have to solve for a variable in order to figure out the other variable. So I'm going to give you a couple of these. There's only two, actually. And we'll go through these practice or example problems. And you can see what I'm talking about. We've already done this, but instead of having subscript variables, we just had x or y. It's the same exact thing we've done before, but I'm going to go ahead and walk you through it. So this is 87.1, and we are told RE and TE, or RE times TE, equals RW times TW, right? Then we're also told that RE equals 200 and RW equals 250. And then we are told that TE plus TW equals 9. So in order to solve for TE or TW, we're going to have to pick one and move the other over. So let's solve for TE, and we would say TE equals 9 minus TW, right? Because we're going to subtract TW from both sides. All right, so now we have a substitution that we can put in for TE. So we'll just do that. RE is 200, so RE 200 times TE, which is 9 minus TW, equals RW, which is 250, times TW, which we still don't know what that is. So 200 times 9 is 1800, minus 200 TW, equals 250 TW. So we're going to add 200 TW to both sides. That leaves us 1800 equals 450 times TW. We divide both sides by 450. And that gives us 4 is the value for TW. Now we can just sub this in over here. So TE equals 9 minus 4. TE equals 5. So now we have TE or TW and TE, and that's all we were looking for. So that's all this is. It's just saying, hey, sometimes you're given this and you have to figure out a way to sub in for it. No biggie. All right, we've done this before, but just with X and Y, not subscripted variables. So let's clear the page. We'll do one more just to go over the concept again. And we are given in 87.2 that we have R1 times T1 plus R2. All right, come on, pen. All right, R2 T2, no Star Wars jokes, equals 360, right? Then we're told that R1 equals 30 and R2 equals 40, and that T1 plus T2 equals 10. So we're going to just subtract T2 because this is the easiest one. T1 equals 10 minus T2, right? So let's go ahead and rewrite this. So R1 is 30 times T1, which is 10 minus T2, plus R2, which is 40 times, I don't know why I did that, 40 times T2, and that equals 360. So that's 300 minus 30 T2 plus 40 T2 equals 360. Subtract 300 from both sides. And then combine these two. So that'll be 10 T2 equals 60. So T2 equals 6. And if we take this value for T2 and put it in here, we get T1 equals 10 minus 6 equals 4. So T1 equals 4 and T2 equals 6. Easy peasy. You guys can do this. This is a walk in the park for you. You've done much harder math than this, and I know you guys can work this out. So let's go on to 87B, the second part of this lesson, and it's just how to test for a function when you don't have the points or the ordered pairs to look at. All you have is a graph to look at, right? So we're going to do something called a vertical line test. And remember, your vertical line is your y-axis. So we're testing for the x value by looking at our y-axis. So let me use a different color line. So we're going to take, this is a graph. Yeah, eventually y'all will graph some of those. And we're just going to take a different color line, and we're going to draw a vertical line at some point anywhere on this graph. And I'm just going to pick one. I'll pick this one. All right. Vertical line. How many points of intersection? Just one. Okay, let's pick another line. Just one point of intersection on this line also. So we're running parallel to the y-axis, and we're looking for more than one x value is what we're doing. If it only has one point of intersection, then that means it only has one x value. And if there's only one x value for each y value, then that means it is a function. So yes, this is a function. All right. So let's look at another, I'll just draw it right here. You might have something that looks like this. It is possible for you to draw a circle. It can happen. I'm here to tell you. So if we do the vertical line test on this, just anywhere, we have 1, 2 points of intersection on the same y value, or I'm sorry, on the same x value. So x can't have two y values, can it? No. So that means that this is no, it's not a function, it is a relation. All right, so you see how that works? You're looking to just have one point on your vertical line, wherever you end up putting your vertical line. All right, and that means anywhere. You could put it right here, where it just has that one point, but you need to be able to put it anywhere. So in the middle here too. So do a couple of vertical lines to test for a function, to test your graph for a function. If you can't put that line anywhere and just get one point of intersection, then it is not a function. All right, so I have some that I've already done down below. And we're going to look at these. And this is practice problem 87.3. This is the only one we have for these. And I've already done them for you. I've drawn a vertical line here, and we have 3 points of intersection. So no, this is not a function. On this one, we've drawn 2 vertical lines, and we only have 1 point of intersection on both of those lines. So this is a function according to this graph. On this one, I've drawn 1 vertical line, and I had 2 points of intersection. If I drew another vertical line out here, I'd still have 2 points of intersection. So no, this is not a function. That's all the vertical line test is. It's just visually determining whether or not it's a function by looking at how the x value lines up against the y values. And you only want to be able to have one y value, which is the crossing of the line, for the x value, which is going to line up with the x-axis. That's what we're doing. Okay, so that is all I have for lesson 87. I will see you guys in lesson 88.